Nice launch trajectory and countdown net. Pad is clear.
10, 9, 8,
Launch auto sequence has
7,
started.
6, 5, 4, 3, 2, 1.
Go for launch.
Vehicle is supersonic.
Stage separation confirmed. Dragon, separation confirmed. Stage 1 is transonic. Landing legs have deployed. And Falcon 9 has landed.
Good morning. It's Saturday, November 12th, and you're looking at a live view of Falcon 9 awaiting its 11:06 a.m. Eastern Time launch from Space Launch Complex 40 at Cape Canaveral Space Force Station. Welcome to our live coverage of the Galaxy 31 and Galaxy 32 mission for our customer Intelsat. Today's launch marks our 190th mission overall to date and our 52nd launch this year. Now, my name is Shiva, and I'm a space operations engineer here at SpaceX, and I'm joining you today from our headquarters in Hawthorne, California. Today's launch continues Intelsat's Galaxy Fleet Refresh Plan, which started with Galaxy 30 in 2020. These assets will provide continuity for C-band media services serving North America. Now, both the Galaxy 31 and 32 satellites were manufactured by Maxar Technologies and are scheduled to enter into service in early 2023. Here's more about the payloads we're flying on today's mission. We're just about 7 minutes away from liftoff, so let's get to know a little bit more about the launch vehicle. Now, the Falcon 9 you see on the pad is a two-stage rocket designed and manufactured by SpaceX for the reliable and safe transport of both payloads and people into Earth orbit and beyond. Now, as a reminder, Falcon 9 is the world's first orbital class reusable rocket, and reusability is important because it allows us to refly the most expensive parts of the vehicle. That in turn is what allows us to drive down the cost of access to space. Now, the entire vehicle stands 229 feet tall. That's slightly taller than the towers of Westminster Abbey in England.
Stage 1, RP1 load complete.
The bottom 2/3 of the vehicle is called the first stage. It's also known as the booster. Now, its job is to accelerate the vehicle from the pad through the Earth's atmosphere into space, and then it'll separate from the rest of the rocket. Today's booster is flying for its 14th time, previously having supported Dragon's first crew demonstration mission, the RadarSat Constellation mission, Sirius XM-7, and 10 previous Starlink missions. Now, if you look closely at this rocket, you see that we don't have any landing legs here or grid fins, in fact, on this first stage, and that's because we won't be attempting to land this first stage today. Today's mission requires additional propellant that we would normally use for recovery, and so we're going to be using that propellant to take the payloads to orbit. Now, moving up Above the first stage, we've got our second stage that has a single Merlin vacuum or MVAC engine that ignites shortly after the first stage will separate. And it's the second stage that will carry the Intelsat G-31 and 32 satellites to orbit. Now, the payload for today's launch are enclosed inside the 17-foot diameter payload fairing, which is that nose cone structure at the very top of the second stage. It's made of a carbon composite material, and it protects the satellites as we make our way to orbit.
Tanks are prepping for strong back retract.
We'll jettison those fairing halves approximately 3 minutes into the flight, and both of those fairing halves are flight proven, having flown, both of them flying for their 5th times. We'll be attempting to recover them after separation on a recovery vessel named Bob. Now, lastly, that large truss structure next to the vehicle is called the transporter erector, or the TE. We use it to roll the rocket out to the pad and raise it to its vertical launch position.
Combat retract auto has started.
Now, the TE routes vehicle fluids, power, and telemetry from the ground systems to the rocket, and that continues until Falcon 9 switches over to internal power and clears the pad. Now, you might be able to see it there. We've begun to open the clamp arms around the second stage. That's in preparation for transporter erector retract. And that's where the TE will begin to slightly back away from the stage to clear the way for liftoff at T-0 hydraulic systems. There's a call out there for strong back retract. At T-0, the hydraulic systems will actually pull the TE further away, clearing the way further for Falcon 9's liftoff. And you can see there the TE making a small angle with the first stage. You also may have heard some callouts there that we've begun pressurizing the stage in preparation for TE retract. So we've begun pressurizing the system. We use a helium pressurant on Falcon 9 to pressurize the tanks. Now, at this point in the countdown, we are nearly fully loaded with about 1 million pounds of RP1 fuel. That's a type of refined kerosene.
Stage 1, lock slope complete.
And liquid oxygen on the vehicle. We just heard the call out there that liquid oxygen loading is complete on the first stage. We'll hear a similar call out for liquid oxygen loading complete on the second stage. Now, Falcon 9 uses rocket propellant 1 as its fuel and liquid oxygen as its oxidizer. An oxidizer is a type of chemical that a fuel requires to burn, and we chill that liquid oxygen significantly below its boiling point. That allows us to load more mass per volume into the vehicle and get more propellant and performance out of the rocket. Now, in addition to both the RP1 and liquid oxygen, we use a chemical called TTEB, triethyl aluminum and triethyl borane, as an ignition source. When we combine those two chemicals, they produce a hot flame and ignite the RP1 and liquid oxygen to make the rocket go. Coming up, we're about 10 seconds away from liquid oxygen loading complete on the second stage. With that call out, we will be completely loaded with propellants for flight.
Stage 2, lock flow complete.
So with that, we are fully loaded with propellants in preparation for liftoff. We'll see some venting from the transporter erector coming up here. And just a quick status update, both the payloads continuing to look healthy. Weather 90% go. It's a beautiful day of Florida today for that on-time liftoff. There you can see on this wide-angle shot, you can see some venting
Ground gas, launch closeout.
From the transporter erector. We're clearing out the liquid oxygen from the lines in preparation for liftoff. That's totally normal. And coming up about 20 seconds from now, we'll have our next major milestone. That's where Falcon 9's internal flight computers will take control of the countdown. That's where Falcon 9 transitions to startup.
Falcon 9 is in startup.
So from here, the launch team will provide their final go for liftoff.
LD, go for launch.
So with that, the launch director giving their final go for launch.
Nice, 30 seconds.
30 seconds to go. let's watch as Falcon 9 takes Intelsat Galaxy 31 and 32 to orbit.
Seconds. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And liftoff of Intelsat Galaxy 31 and 32. Go Falcon 9.
Vehicles pitching downrange.
M1D chamber pressure is nominal.
Successful liftoff of Falcon 9 from Space Launch Complex 40 at the Cape Canaveral Space Force Station in Florida. We're carrying the Intelsat Galaxy 31 and 32 payloads to orbit. Now, we've just begun throttling down the Merlin 1D engines in preparation for maximum dynamic pressure. And we've also begun to tilt the engines. That's called gimbaling, and that's why we've begun to move horizontally away from the launch pad. That maneuver is called a gravity turn.
Max Q.
So call out there for max Q, that's the point of maximum aerodynamic pressure. Now briefly going back to the gravity turn, we are still heading up. As you can see, the speed and altitude are increasing, but we're also heading away from the launch pad. And we do that because a rocket needs to go about 17,500 miles an hour horizontally in order to avoid being pulled back to planet Earth. So we'll keep speeding up the vehicle to get to orbit. Now coming up in about a minute, we've got three events back to back. That is main engine cutoff, followed by stage separation, and then second engine start number 1. Main engine cutoff is where we'll shut down all 9 of the Merlin 1D engines on the first stage. That's in preparation for stage separation, where the first stage will push off the second stage, and then second engine start number 1, where we'll ignite the Merlin vacuum engine on the second stage. So again, MECO, main engine cutoff, followed by stage separation, and then SES-1. And gotta love those beautiful views. This is a view from the first stage camera looking down the body of the first stage towards planet Earth. You can see the Merlin 1D's plume expanding as the density gets less and less.
MECO. Stage separation confirmed.
And vac ignition.
Stage 1 FTS is saved.
Awesome. So MECO, stage sep, and second engine start complete. Now coming up next in about 20 or so seconds will be fairing separation. Again, both of these fairing halves having flown 5 times before today's mission. And some great views of planet Earth behind the Merlin vacuum engine.
Fairing separation confirmed.
So there is successful fairing separation. We'll be attempting to recover those fairing halves again once they make their way back to Earth on a recovery vessel named Bob.
Acquisition of signal.
You can actually see one of the fairing halves in frame there as it goes back to planet Earth. We actually got our first glimpse of the payload as well today. As a reminder, we are not attempting landing on our first stage. So the next major milestone will be second engine cutoff number 1. That's about 4 minutes from now. And again, the reason we're not attempting to recover our first stage today is because today's payload needed a little more performance out of Falcon 9. And so we had to use the propellants that we would normally use for the entry burn and landing burn to instead take the payload to orbit. Now, the first of these two burns is taking us into what's called a parking orbit. So that is a roughly circular orbit that we'll be going into before we take a second burn later on in today's broadcast. And ultimately, the payloads will be going to what's called a geostationary transfer orbit before they continue their mission onto geostationary orbit. So for this first burn, the Merlin vacuum engine is continuing to burn and take the second stage and the payloads to orbit. Now, the Merlin vacuum engine is extremely similar to the Merlin 1D engines. It does feature more redundancy and a much larger expansion nozzle, and that allows us to maximize the efficiency of the burn in space. And the reason that that expansion nozzle makes the burn more efficient is because we're able to expand the gases further in the vacuum of space than we are on the ground. On the ground, we've got about 14 pounds per square inch of pressure from the atmosphere pushing down on us. And so as you try to expand a gas, you have to keep the pressure matching with that atmospheric pressure. And that means you can't get as much push out of the gas out of the nozzle. But in the vacuum of space, we don't have to contend with that. And so we can actually get more of the force out of the expanding propellant to push the second stage, and that increases the efficiency. And Merlin Vacuum operates with the highest efficiency ever made for an American hydrocarbon rocket engine. Now, you may have noticed on the pad that the second stage looks very similar to the first stage. It doesn't just look similar, it has the same diameter, it uses the same metal composition in the tanks, the same computers, and the same propellants, and almost the same engine. And that allows us to use similar tooling, design techniques, and systems to build two rockets that are more reliable. Anything that we learn on the first stage often applies to the second stage and vice versa. Now, if you're just joining us, welcome. You're watching our webcast coverage of the Intelsat G-31 mission.
Trajectory is nominal.
You've got a view of the second stage Merlin vacuum engine, along with planet Earth behind us. We're about 4 minutes in to a 5-minute burn. We had successful liftoff, stage separation and second engine start, as well as fairing separation from Space Launch Complex 40 at Cape Canaveral Space Force Station. And we didn't attempt to recover our first stage today as we needed the propellants for additional performance to get our payloads to orbit. Now we're currently awaiting second engine cutoff number 1, or SECO 1. That coming up in just about 20 seconds from now.
Terminal guidance.
Stage 2 FTS is saved. Expected loss of signal Cape Canaveral. MVAC shutdown.
There is successful confirmation of SECO 1. So now the teams are going to be evaluating the orbit that we're in. Make sure that we're right on track.
Nominal orbit insertion.
And with that call out, we are in a nominal orbit. Again, this is the first orbit. It is a parking orbit in preparation for our next event. And since we didn't attempt to land our first stage today, the next major milestone will be ignition of our Merlin vacuum engine again. That's for second engine start number 2, expected in about 26 minutes. Excuse me, about 26 minutes into the mission. So until then, please enjoy the space tunes and the views from space. We'll see you back at about T+26.